Okay, so this is from last time. You have you want to send something to someone, right? But you have two keys. One is the public key, and the other is private key. To be able to, if you encrypt with public key, the only way you can decrypt is to use your private key, and it works on the other way around. If you encrypt with private key, you can decrypt with public key. The public key, as the name suggests, should be public. Can be public. You can give the public key to anyone else, so people can encrypt a message and send it to you. But you will be the only one who can decrypt it because you have the private key. Okay. In RSA is one way to implement the public-private key cryptography. There will be three numbers, E, N, and D. Okay. The public key เข้าได้ไหมครับที่ช่วยหน่อยดึงแรง So the public key and the private key. The key consists of two numbers. Okay, one the public key has two numbers, E and N. The private key has two numbers as well, D and N. Okay, N will be the key to the difficulties of the secret. Our secret will be hidden inside N. Okay, and the way you encrypt and decrypt is by do the exponentiation. If you want to encrypt M with public key EN, you compute the message and you raise it to the power of E, and then you modulo N. When you want to decrypt, you take the encrypted message and you raise it to the power of D and you mod N. So that's the operations. How you come up with E and D and N, we will see that in the exercise. Okay, so in here you use most of my code, and then later on you'll be able to write it on your own. Okay, so you can read. Okay, so to encrypt we raise M to encrypt message M. We raise M to the power of E and you mod N. Okay, and to decrypt we raise the encrypted message to the power of D and mod N. Okay, mod is exactly the modulo operations. You find the remainder. Okay, that's the operation that we previously talked about. Okay. All right. So you need to compute the power in Python. Because M and D, E and D will be a really large number, like millions or billions. Okay. To compute M raised to the power of E or the K raised to the power of D, it take a long time. If you do that directly, okay. But Python, but if you do that modulo N, okay. Let's see what it means. Okay. When you do something modulo N, okay, so when you compute, when you encrypt, okay, suppose you have message M, you want to encrypt, right? So you raise M to the E and then you mod the result with N, okay. If M is a 100 digits number and E is like 1,000 digits number, you raise M to the power of E, you have like a number with like millions digits. Okay, that will take a long time to compute. Okay, however, modulo operation is a magic here. Okay, let me show you. So when you compute modulo, you can compute the whole thing, the whole expression, and perform the division to get the remainder, the modulo, the result, the modulo. But you don't have to do that. Okay, because we have this. We know that A plus B mod N will be equal to A mod N plus B mod N, and then you mod N at the end. Okay, so we can prove all this, and it holds not only just additions, multiplication as well. So if you have A times B and you want to mod N, it's going to be equal to A mod N times B mod N and then you just mod n. Okay, mathematically it doesn't make sense to like do the mod inside, but computationally, if you write your program, if a will be a really large number, if a is large number, b is really large number, but n is not that large, okay, when you compute the multiplication here, you will get a really large number, right? And then when you do the mod, it will take some time. But if you mod a with n before the multiplications, you can reduce the magnitude of the numbers that you are working with. So you can make sure every number that you work with will be, if you mod n, the number will be at most n, right? So you make sure that all the numbers in your system is not going to be that large. Okay, so every computation will be not that won't be too slow. So let me show you one example. In the exercise, if you need to do the computation, or do you have Colab? You know how to use Colab, right? Okay. Suppose you want to compute and you raise to the power of, okay, and you want to mod. So let's say just this, and then you want to mod this. Suppose you want to compute this. If you compute the whole thing directly, this thing, your machine will crash. Okay. So let me do that. What? Too fast. Okay. Yeah, it doesn't work, right? So it exceeds the limits. The number of digits that you have is like too long for Python. Okay. But if you modulo everything with, but you don't, what you want, you don't want the actual results, right? You want the modulo of this. So you can perform the computation while keep modulo everything with the modulus, these numbers. So all the numbers will be not too large, and then you can do the computations. And this function pow, do exactly that with some other optimizations, because the exponential, when we do it, will be like trillions. If you just keep multiplying stuff, it will take a long time, because you need to do like a trillions multiplications. That may take a minute. Okay, but in RSA, the exponentiation will be like some 1,000-digit numbers. If you really do the exponentiation by keep multiplying, it will take forever. Okay, we'll see how we could do that. We'll see what inside function pow of Python later on, but now we need to use it. Okay. Okay, so let's try to work on this. First of all, there's a few to-dos here. Okay, so you keep reading it, and we start with this key pairs. So the public key is this 65537, and this is the value of n. Okay. So the first to do is like I give you the public private key, and then you should try to encrypt the message that I gave you. Okay. Now the second to do is to ask you to generate a key pair. Okay. So to generate a key pair, you need to pick two large prime numbers. So go to this page, prime page. Take some of this. Okay. Or if you take inside, it will be a zip file. Sorry. So take one of them. Take some of this. Okay. Any one of them. Two of them. Okay. And then use one as a P. Use another as Q. Given these two numbers, we have the modulus. Okay, so you can compute the value of n. N will be P times Q. Okay, so take two numbers, put it in here, run the code, and use E. We will fix E with these numbers. Usually works. And finally, you need to compute D. D is a number such that this equation holds. We'll see why we need this later on. But to find this value D, you run this code. The code is called file inverts. File inverts. And now, after this, you have this public key and private key. Okay, so you should take this public key, okay, and post it in here. To do so is to look at the public key that your friend posted and then put it in here and write some other message here. M will be some big numbers, whatever number you like, and then encrypt or encrypt. After you done the encryption, you should see the encrypted message. Okay. When you have this encrypted message,